Welcome, Calculus AB. This is section 1.5, infinite limits. The essential question is, do infinite limits exist? Let's begin. So what are infinite limits? Well, let's take this function right here of 3 over x minus 2. I'm going to ask you, what's the limit of f of x as x approaches 2? Well, as you're approaching 2 from each side, we usually say this does not exist because it's going to negative and positive infinity. It's two different ones. But if they said the limit as x is approaching 2 from the left-hand side here, we're going down. It's an asymptote down to infinity. So I'm going to say it's negative infinity. And limit on the right-hand side, you're actually going up, but you're going up to positive infinity. So I'm going to call that positive infinity. So these are infinite limits. We're instead of saying it doesn't exist, we're actually going to write infinite. But here's a question you're going to have. So a limit is f of x increases or decreases without bound as x approaches c. That's the official definition. But wait, doesn't this conflict with what we learned before? Didn't I say if it's an infinite interval, right? You can't do that. If it goes to negative or positive infinity, we say it doesn't exist. I did say that, and that's still true. But when you say positive or negative infinity, it says the limit fails to exist by saying that, hey, it's going to negative or positive infinity, so it still doesn't exist, but we're saying why it doesn't exist, because it's going to positive or negative infinity. So there's the subtle difference. Oh, there's nothing there. Okay, let's keep going. So I want to determine the limit of each function shown up here as x approaches 1 from the left and right. So from the left and right. So 1 from the left side, if you're approaching the limit, we'll call this as x approaches 1 from the left, you're going to positive infinity. Now the limit as x approaches 1 from the right, you're also going to positive infinity. So we write infinity. Now on this one, the left, the limit as x approaches 1 from the left, you're going to positive infinity. But as limit as x approaches 1 from the right, it's going to negative infinity. Now vertical asymptotes. So going back to a little bit of this rational functions. The definition of vertical asymptote here officially, f of x approaches infinity or negative infinity as x approaches c from the right or left. Then the line, this dotted line, is a vertical asymptote. So that means that you're approaching positive or negative infinity, and the graph never hits that. So that's the official definition. So where are vertical asymptotes are going to happen if f and g are continuous, and so f of c is not 0 and g of c is 0. So basically you have some number here, and we don't have to read all this. There's some number on top, but it's divided by 0. So it's like some number, I'll call this 1 divided by 0. These are vertical asymptotes. Notice that's not when 0 is divided by 0. Not that. It's something divided by 0. That's going to create vertical asymptotes. So in this first case, where's the vertical asymptote that's going to happen? That's going to happen, you're only divided by 0 when x is equal to negative 1, because that'll make it 0 on the bottom. Now for this next one, where's the vertical asymptote going to happen? That's when x equals 1 and negative 1, because both those values would make that denominator 0. For cotangent of x, cotangent is cosine over sine. So basically when sine of x equals 0, when you're dividing by 0, that's your asymptotes. And that's going to happen when x equals sine is your y values, when it equals 0, pi, and 2 pi, and so on. So every pi value. So let's find the vertical asymptotes here. So what values would make this 0? Now the first thing you have to do is, we want to factor this because it's not going to be an asymptote if things cancel out. That's just a discontinuity. That's a point of removable discontinuity. So factoring the top, I don't care how you factors, multiply negative 8 adds to 4 is going to be x plus 2 times x minus 2. On the bottom is going to be its difference of squares, x plus 2 times x minus 2. What cancels out here? The x minus 2. So all you're left with is x plus 4 over x plus 2. Your vertical asymptotes are going to happen when x equals negative 2. So the other asymptote, positive 2, is not going to work. And if you did this graph, it's roughly going to look, x is negative 2. You're going to have an asymptote here. But then when you had x is positive 2, it's just going to be an open hole. And so it's going to look something like this with an open hole at 2. So that's what that side. And the other side is going to look like this. That's a bad sketch. So let's find the limits of these functions. So here's I graphed it over here. The limit as 1 approaches from the left-hand side. So if you're looking at this graph, it's actually this is going to be approaching infinity. Now another way to do this, and on the right hand, no, I'll skip that. On the right hand side, it's going to be approaching negative infinity. What was the point of that? Moving on. All right, so a little bit of the properties of infinite limits. So if you have the sum, let's say f of x is infinite, and g of x is just some number. Okay, so it's a regular limit. So if you add those up here, hey, are we listening? You're being recorded. Tens and tens of you are listening to this right now.
Hi.
Hi. Devin, you can get out of the closet. Thank you. This is going to stay in the tape.
Devin came out of the closet.
So the sum of the difference. So if f of x equals infinity, if you add them up, this is like adding up infinity plus some number L. That's still going to be infinity. If you multiply infinity times some number, it's still infinity. If you multiply, now if L was negative number, so if you multiply infinity times like -1, you get negative infinity. And if you take some number g of x divided by fx, so that's some number, let's call it like 1 over infinity, any number over infinity, it actually evaluates to 0 because 1 over something really, really, really big. So that's that. All right, so if we do some examples here, this is like 1 plus, as x approaches 0, this is infinity. The limits there is going to be infinity. That's like 1 plus infinity. This one right here, okay, so for the next one here, you're dividing as that approaches negative infinity. So this is going to be 2 over negative infinity, which is going to be 0. And for this one, it's 3 times. This is going to be 3 times infinity, basically, for the limits, which is still going to get you infinity. And that's it. Boom.